Hi students, so good evening everyone. Hi, okay, good evening to all. Good evening and welcome to all of you for the evening session. Okay, so here we are solving model paper 3 and now we can continue our questions from part C one by one. So quickly all of you join the class so that we can start the class as much as early possible. So tell all your friends to join the class because we have to start as soon as possible. Okay, otherwise it will get late and it is not good if it starts very late. Clear? So we are solving model question papers of your Karnataka board exam. So already we have solved two model papers. Now this is third model paper and now we can go for the part C of the third model paper. Clear? So quickly all of you tell your friends to join the class so that we can continue with our part C, problem number 25. I hope that all of you are very much fine and good with your health as well as uh, all your conditions, because you have to be very safe these days. To be safe, just to be in home. Okay, so now we can start our class. Okay, we shall start with problem number 25. Okay, so just see problem number 25, that is prove that the relation R in the set of Z defined by R equal to order pair x comma x such that x minus y is an integer is equivalence relation. Okay, so now we have to go for an equivalence relation and we have to solve it. So when you say it is an equivalence relation, if it is reflexive, symmetric and transitive, we say it is equivalence relation. Okay, so for that first we have to prove it is reflexive, next we have to prove it is transitive, symmetric, and last we have to prove it is transitive, so that it is going to be an equivalence relation. Clear? So quickly we can go through it. That is problem number 25. Okay, so you just see this, that is problem number 25. Let us take, let let z be the z of let z be the set of integers. Let z be the set of integers, the set of integers. So now R is defined as R is equal to set of x comma y such that x minus y is an integer. X minus y is an integer. Okay, so if x minus y is an integer, now here you just see x minus x is equal to what? So x minus x is equal to 0. All of you know that. So that is 0 belongs to integer, that is z. So 0 belongs to integer, that means x minus x belongs to integer. Okay, so for every x belongs to z, for every x belongs to z, order pair x comma x belongs to R, so that it says so it is reflexive. So it is reflexive. Okay, so it is reflexive. Clear? Because we know that x minus x is 0, 0 is integer, that means x minus x belongs to integer. Clear? So this is true for every element in the Z. It is true for every element in the Z. Therefore, order pair x comma x belongs to R for every x belongs to Z. So it is reflexive. And you can also see that given, what is given? X minus y is integer. X minus y is integer. Okay. So if x minus y is integer, that is given, x minus y is integer. So now you can just see x minus y is going to be equal to minus of y minus x. Okay. By taking minus sign, you can write x minus y as minus of y minus x. So that it implies what? Y minus x also belongs to integer. Y minus x also belongs to integer because it is equal to x minus y. So therefore from this you can see that x minus y is an integer, means x comma y belongs to R. On the same way, y minus x belongs to integer, means it implies y comma x belongs to R. So therefore you can say that it is symmetric. Therefore you can say that it is symmetric. Clear? Y comma x belongs to R. So here given thing is what? Given thing is x minus y is integer. So x comma y belongs to R. Okay. So now we know that x minus y is equal to what? Minus of y minus x. So that implies y minus x belongs to integer because that is equal to x minus y. So therefore this says y comma x belongs to R. Therefore x comma y belongs to R implies y comma x belongs to R. Therefore it is symmetric. It is symmetric. Okay. It is symmetric. Clear? So for transitive you see, let x minus y be an integer. Let x minus y be an integer. And y minus z be an integer. Clear? So we know that if we add two integers, again we will get integer. So that's why I will add x minus y plus y minus z, because we know that if we add or subtract two integers, again we will get an integer. So here minus y plus y will get cancelled. You are going to get x minus z. So now it implies what? X minus z belongs to R. Clear? So x minus y is an integer, means x comma y belongs to R. Y minus z is an integer, means y comma z belongs to R. It implies what? X comma z belongs to R. Okay. So if x comma z belongs to R, then we say that it is transitive. It is transitive. Okay. So here quickly everyone, please tell me, have you understood this or not? For reflexive you have to take x minus x. For symmetric you have to take x minus y equal to minus of y minus x. For transitive you take x minus y and y minus z. If I add those two terms, minus y plus y will get cancelled. You will get x minus z. So therefore x comma z belongs to R. So you can say that it is transitive, hence it is equivalence. Hence it is equivalence relation. Hence it is equivalence relation. Okay. So now if all of you give me thumbs so that we can quickly go for the next problem, that is problem number 26. If all of you give me the thumbs, quickly we can go for problem number 26. Clear? Okay. So see problem number 26. Problem number 26 tells that if A and B are symmetric matrices, of same order, then show that AB is symmetric if and only if AB equal to BA. That means A and B commute. That means commutative. Okay. So here what is given, first you write. The given thing is A and B are symmetric. So A is symmetric means A equal to A transpose. B is symmetric means B equal to B transpose. Okay. Then show that AB is symmetric if and only if AB equal to BA. So my dear students, you see here, if AB has to be symmetric, it has to be equal to AB equal to whole transpose. Okay. If AB has to be symmetric, it has to satisfy AB equal to AB whole transpose. So you take this as equation 1. So we all know that AB transpose is equal to B transpose into A transpose. Okay. So that I will use here. So AB whole transpose is equal to B transpose A transpose. This is from the properties of matrices. Okay. So now you can just see B transpose is equal to what? B. They have given that B is symmetric. So B transpose is equal to B. From this you can write. So B transpose is equal to B and A transpose is equal to A. From this you can write. No problem. So now you just see here. AB whole transpose is equal to what? What you are getting? AB whole transpose is equal to what? BA. So from equation 1, what I can write? I can write AB whole transpose or you can take it as 2. Okay, from equation 1 and equation 2. From equation 1 and equation 2, you just see AB whole transpose is equal to AB. And equation 2 tells that AB whole transpose is equal to BA. So equation 1 and equation 2 gives us AB equal to BA. That is AB is equal to BA. Okay. So that means AB is commutative. AB is commutative. Okay. So very nice question. And so many of students don't write this because they will be not knowing the properties of symmetric matrix. They will be not knowing the properties of AB whole transpose is equal to B transpose A transpose. So that's why so many of students won't write this question, but you all don't miss this very simple question. So you can write as I solved. Okay. So everyone quickly give me thumbs if you have understood this. Quickly give me thumbs everyone if you have understood this, because it's a very good question that you can understand it. Okay. So quickly give me thumbs everyone so that I can go for question number 27. You can just see question number 27, that is x is equal to what? X is equal to a into cos t plus log of tan t by 2. Okay. Y is equal to a sin t. Clear? So now from this you can just see I will calculate dx by dt. From this you can just see I will calculate dx by dt, that is equal to a differentiation of cos is minus sin t plus, be careful to differentiate log of tan t by 2. You have to be perfect with chain rule. I will not write d by dx. In one shot I will write all the solution of log of tan t by 2, that you have to understand. Okay. Directly I will apply chain rule and I will write this so that we can reduce 1 or 2 steps. That will be very helpful for us. We know that differentiation of log is what? 1 by tan t by 2 multiplied with, after that differentiation of tan is what? Secant squared t by 2 multiplied with differentiation of t by 2 is what? 1 by 2. Okay. So like this you have to solve. In every step don't write d by dt like that. Clear? So you can reduce the strength of you can reduce the time taking solution for this. So that's why be careful. Okay. So minus sin t plus, so here you can just see 1 by tan t by 2 is cot t by 2. Cot t by 2 is cos t by 2 divided by sin t by 2. And secant squared is nothing but 1 by sin square t by 2. And 1 by 2 is as it is. Okay. So now second square is 1 by cos square. Second squared is 1 by cos square, not sin square. 1 by cos square. Clear? So therefore we can write it as 1 by cos square t by 2. So now cos t by 2 will get cancelled. That will be equal to a times of minus sin t plus. So 2 times of sin t by 2 cos t by 2 is what? 1 by sin t. Okay, this is nothing but 2 times of sin t by 2 into cos t by 2. That is equal to sin t. I am using sin angle sin 2t formula. Okay. So now you can just simplify by taking LCM. That will be a into minus sin square t plus 1 divided by sin t. So what is 1 minus sin square t? That will be cos square t divided by sin t. Okay, very good. So now you can differentiate dy by dt. This term, what it will be? A into cos t. A into cos t. Okay. So therefore, to write dy by dx, that will be dy by dt divided by dx by dt. So dy by dt is a cos t divided by a times of, you can just say cos square t divided by sin t. That will be dy by dx equal to a will get cancelled, cos will get cancelled. The remaining thing is sin t divided by cos t. That will be equal to tan t. So this is your required answer. Okay. So everyone, I think everyone can understand this. Very simple problem. If you know the techniques, if you are good at differentiation, and if you have the practice of solving chain rule, you can do this very quickly. Otherwise, some of the students will write this more than one page. This solution, some of the students write more than one page. Don't waste your page, don't waste your energy, don't waste your time. You be very good at your differentiation. You be very good at your differentiation, so that it will be very easy. Okay. So that you can just see here, this is nothing but 2 times of sin t by 2 cos t by 2. Some of you are asking t by 2. Okay. So what is sin t by cos t? That is tan t. Okay. So answer is tan t. Clear? So quickly give me thumbs. All of you, if you have understood this, quickly give me thumbs, so that we can go for the next problem. Okay. That is problem number 28. Problem number 28. Okay. Find dy by dx if x into y is equal to e to the power of x minus y. No problem. Here you have to apply u into v rule. So therefore, x into dy by dx plus y into 1. So I think everyone can understand this, because differentiation of y is dy by dx plus y into differentiation of x is 1. And e to the power of x will be what? E to the power of x minus y multiplied with differentiation of x minus y is 1 minus dy by dx. Here also I am applying chain rule. For e to the power of x minus y. That will be e to the power of x minus y multiplied with differentiation of x is 1 minus differentiation of y is dy by dx. Okay. So now you can just see this, x into dy by dx plus y equal to. So now you just see e to the power of x minus y is nothing but xy. E to the power of x minus y is nothing but xy. So this will be 1 into dy by dx. Okay. So now x into dy by dx plus y equal to xy into 1 is xy and minus xy dy by dx. Okay. So take dy by dx terms on one side, that will be x into dy by dx plus xy into dy by dx equal to xy minus y. take dy by dx on one side, so that remaining terms on another side. Here dy by dx into x is common, so x into dy by dx is common. What is remaining term? 1 plus y into dy by dx. There 1 plus y. Here 1 plus y is common, so that you can write, okay, 1 plus y. Okay, so now this is equal to what? Here y is common, you can take y as common. Remaining term is what? X minus 1. Remaining term is x minus 1. So now you can write it as dy by dx equal to y into x minus 1 divided by x into 1 plus y. X into 1 plus y. So therefore this is your answer. Okay, clear? So quickly give me thumbs if you are following this. Quickly give me thumbs if you are understanding this. That is dy by dx equal to y into x minus 1 divided by x into 1 plus y. And here don't forget to replace e to the power of x minus y as xy. Otherwise you can write it here from equation 1. You can adjust here from equation 1. Okay, so I think all of you have understood this. So I can go for problem number 29. I can go for problem number 29. Okay, so you can just see in the problem number 29 what you have. Find two numbers whose sum is 24 and whose product is as large as possible. So here you can just see, find two numbers whose sum is 24. That is x plus y is equal to 24 and product is as large as possible means I will write it as z. So all of you know that you have to differentiate the equation of z. So before that y is equal to what? 24 minus x. So in the place of y, I will write it as 24 minus x equal to z. Okay, 24x minus x square equal to z. So if I differentiate this, it will be with respect to x. So that will be equal to, differentiation of 24x is what? 24. Differentiation of minus x square is what? Minus 2x. Okay, again I will differentiate this because we have to calculate maximum or minimum. So therefore differentiation of 24 is 0. This is minus 2. Okay, so clearly you can see this is lesser than or equal to 0. Therefore local maximum exists. Local maximum exists. Okay, so now from this you can see, take dz by dx equal to 0. That is 24 minus 2x equal to 0. You have to take, that is nothing but dz by dx is equal to 0. Therefore x will be equal to 12. Consider the equation consider y equal to 24 minus x. So now y will be equal to 24 minus 12 is equal to 12. Therefore 12 comma 12 is required point. 12 comma 12 is required point. Okay, so every step is clear, every problem is clear, and I think all of you also can understand this. All of you can also understand this. Okay, now I will go for problem number 30. Now I will go for problem number 30. So you can just see the problem number 30 is, quickly give me thumbs, problem number 30. Okay, so that is integration from 2x divided by x square plus 3x plus 2 with respect to dx. So some of you try this with partial fractions. Some of you start to solve it with partial fractions. So I will give you some other approach so that you can get answer very easily. What I will do, I will adjust with 2x plus 3 minus 3 divided by x square plus 3x plus 2 with respect to dx. I am approaching with different method, okay, by adjusting the terms. All of you solve with partial fractions, I know, but I will approach it with different method where we can solve it very easily. So here you can write it as integration of 2x plus 3 divided by x square plus 3x plus 2 with respect to dx, and minus 3 into integration of dx divided by x square plus 3x plus 2. Okay. So now integration of this term. See here, it is in the form of integration of f dash of x divided by f of x with respect to dx. So that will be equal to what? Log of mod of x square plus 3x plus 2. Okay. So minus 3 is constant term. You can write as it is integration of dx divided by, I will write it as x plus 3 by 2 whole square and minus 3 by 2 square is minus 9 by 4 plus 2. So that will be plus minus 1 by 4. So that I can write it as minus 1 by 2 square. Okay. So that means it converts for x square minus a square. Therefore, that will be equal to log of mod of x square plus 3x plus 2 minus 3 times of, you can write it as log of x minus a divided by x plus a, that is mod of x plus 3 by 2 minus a divided by mod of x plus 3 by 2 plus a plus c. Therefore, log of mod of x square plus 3x plus 2 minus 3 times of log of, you can just see 3 by 2 minus 1 by 2 is 2 by 2. So 2 by 2 is nothing but 1. That is mod of x plus 1 divided by 3 by 2 plus 1 by 2 is 4 by 2. 4 by 2 is nothing but 2 plus c is your answer. Okay. So therefore, this is your required answer. Clear? So I think all of you can understand this. Otherwise, if you say solve it by partial fractions, we can solve it by partial fractions also. No problem. So if you want partial fractions, we can go for partial fractions. If you want to solve it by shortcut methods like this, you can solve it by shortcut methods also. So by partial fractions, everyone will solve. I think all of you can also solve it. You learn one new method which I have solved now. Okay. So that I can go for quickly for the next problem. Quickly I can go for the next problem. Clear? So quickly tell me everyone, can I go for the next problem? That is problem number 31. That is problem number 31. Okay. Okay, so let us go for integration of x into log x with respect to dx. Clear? So here you can just see, you have two functions. We can go for isolate method. You can go for isolate method. So isolate, a means algebraic, l means log. Log is first function, a is second function. So therefore, log x is the first function. We will write as it is. Second one is your algebraic function. We will integrate x, that is going to be x square by 2 minus integration of, we have to write x square by 2. We have to write x square by 2 as it is, multiplied with differentiation of log x is what? 1 by x with respect to dx. So x get cancelled and the remaining term is what? Log x into x square by 2, and here the remaining term is integration of x by 2 with respect to dx. So that will be log x into x square by 2. Now you can integrate it again, so that it will be x square by 4 plus c. Okay. So Rafiq and some of you are telling solve it by partial fractions. No problem. I will solve it by partial fractions at the end of this class. First we shall complete all the problems and we can go for partial fraction. Okay. So what about others? Have you understood that method? Otherwise we can solve it by partial fractions also at the end of this session, no problem. So now let us go for integration of sine 3x cos 4x with respect to dx. Okay, so here you have to apply sine a into cos b formula, that is 1 by 2 into sine of a minus b minus sine of a plus b minus sine of a minus b. Okay, so you have to apply that rule. That will be integration of 1 by 2 I will take outside. Sine of 3x plus 4x is 7x minus sine of 3x minus 4x is minus x with respect to dx. So this is going to be 1 by 2 into sine of 7x minus into minus is plus sine x with respect to dx. Okay, so now 1 by 2 into integration of sine is what? Minus cos of 7x divided by 7. And you can see here also integration of sine x is what? Minus cos x plus c. This is your answer. Okay, minus cos of 7x divided by 7 minus cos x plus c is required answer. Okay, all of you quickly give me thumbs if you have understood this. Minus cos of 7x divided by 7 plus, and here this is minus cos x plus c. Okay, now we can go for problem number 33. So quickly tell me everyone, are you following the classes? Are you following the problems? Are you understanding the problems? What about problem number 30? All of you quickly reply me about problem number 30. At the end, if you want, I will solve it by partial fractions. You can get the answer, no problem. Okay, otherwise we can wind up with the end of all the problems, but no problem. Now we are going to problem number 33. Now we are going to problem number 33, that is find the area of the region bounded by y equal to x square. So this is y equal to x square and y equal to 4. This is y equal to 4. Now if you want to see the bounded area, this is going to be the bounded area. This is going to be the bounded area. Okay, so here now you can just see y equal to x square. So if I take x equal to, it will be root y. Here we have to differentiate with respect to y. Therefore required area will be equal to 2 times of integration from 0 to 4, 2 times of integration from 0 to 4 root y with respect to dy. So therefore you can just see 2 times of this will be root y is nothing but y to the power of 1 by 2 plus 1, that is 3 by 2. 1 by 2 plus 1, 3 by 2. So that will be 2 by 3 y to the power of 3 by 2. 0 to 4. Lower limit is 0. You can neglect it. No problem. 2 into 2 by 3. Upper limit is 4. So 4 to the power of 3 by 2. So therefore 2 square. It will be 4 by 3. This is 2 square whole to the power of 3 by 2. 2 will get cancelled. So therefore answer will be 4 into 2 root 2. So that is 8 root 2 divided by 3 square units. You can write it as 2 cube is 8. 8 into 4 is 32. 2 cube is 8 and 8 into 4 is 32. Okay. Clear? So see this. 2 cube is 8. 8 into 4 is 32 by 3 square units. 32 by 3 square units will be your answer. Okay. So very simple problem. Don't get confused. You just go through it, and before solving you must know what is the formula of integration, how to solve application of integration problems. Those all things you must know. Blindly if you go means you can't understand anything. So now let us go for problem number 34. that is, find the general solution of the differential equation dy by dx is equal to 1 plus x square divided by 1 plus y square. So now it is going to be equal to 1 plus x square into 1 plus y square. 1 plus x square into 1 plus y square. One plus x square into 1 plus y square. So that is dy by 1 plus y square 1 plus x square into dx. So now integration on both sides. Integration of dy divided by 1 plus y square, integration of 1 plus x square into dx, that is tan inverse of y, here x plus x cube by 3 plus c. Okay, integration of dy divided by 1 plus y square will be tan inverse y, and integration of 1 is x, integration of x square is x cube by 3 plus c. Okay, now let us go for problem number 35. Show that the position vector of the point P which divides the line joining 2 points A and B in the ratio m is to n, in the ratio m is to n is m vector B plus n vector A divided by m plus n. Okay, so now let us take line passing through 2 points. Let us take this is A and let us take this is B and take one arbitrary point P which divides in the ratio m is to n. To join O to A, that is vector A, join O to B that is vector B. From the diagram you can just see that AP vector divided by PB vector is equal to m by n. Okay, now OP vector is vector R. Clear? In the previous question paper also we have solved this. So therefore from this we can write OP vector minus OA vector divided by OB vector minus OP vector equal to m by n. OP is vector R, OA is vector A divided by OB is vector B, OP is vector R equal to m by n. So now from this vector R minus vector A into n equal to m into vector B minus vector R. From this vector R dot n minus vector A dot n equal to m dot vector B minus m dot vector R. So therefore you can just see, replace the terms, vector R dot n plus m vector R is equal to m vector B plus n vector A. You can take R common, m plus n equal to m vector B plus n vector A. Vector R will be equal to m vector B plus n vector A divided by m plus n. This is your answer. Okay. So now you can just see we have solved the formula of bisection of bisection of a line with internal point P. Bisection of a line with what? Internal point, that is P. Clear? So everyone, have you understood this? Quickly give me thumbs. Quickly give me thumbs if you have understood this, so that we can quickly go for problem number 36, 37 and 38. We can go for problem number 36, 37 and 38. Okay. So you just see problem number 36. What is problem number 36? A, B, C are the three vectors given by mod of vector A equal to 3, mod of vector B equal to 4, mod of vector C equal to 5. Okay. So my dear students, if you lose the connection, it will be the problem of power cut, because it is raining. So I think power may just disconnect our connection. If it disconnects, you just think that power it is the problem of power cut. Okay, so now we can go for mod of a equal to 3, mod of b equal to 4, mod of c equal to 5. Each vector is orthogonal. Each vector is orthogonal means vector a dot vector b equal to 0, vector b dot vector c equal to 0, vector c dot vector a equal to 0. Because they are orthogonal means they are perpendicular to each other. Okay, then we have to find sum of orthogonal to sum of the okay, each vector is orthogonal to sum of other two vectors. Okay, so sorry for this here, I have not read question fully. One of the vector is orthogonal to sum of the other two vectors means one of the vector is orthogonal to sum of the other two vectors means it will be like vector a dot vector b plus vector c equal to 0, vector b dot vector c plus vector a equal to 0, vector c dot vector a plus vector b equal to 0. Okay, so now you can just see, if I simplify this, vector a dot vector b plus vector a dot vector c is equal to 0, vector b dot vector c plus vector b dot vector a is equal to 0, vector c dot vector a plus vector c dot vector b equal to 0. Now what I will do, I will take this as equation 1, I will take this as equation 2, I will take this as equation 3, and I will add 1 plus 2 plus 3.